Okay, I welcome all the students. Today we are going to learn the demonstration of, or we can say the implementation of 2D rotation. Okay, in the previous session we have learned theoretically how this 2D rotation works, or the concept of 2D rotation along with its matrix multiplication, its formula which we can use for the x dash and y dash values. Now today we are going to learn this with the in detail. We are going to learn the implementation of 2D rotation with the help of the C program. Save the time instead of typing the complete program. Okay, I have typed the program as per our theoretical concept or the program algorithm or the formula. Okay, so let us open the program. I'm opening here the 2D rotation. Okay, okay. So you can find initially we have written the name of program is 2D transformation. Under that we are learning the rotation. Okay, now here we are learning the rotation of the object not only from the origin, okay, but rotation also from arbitrary, or generally we call it as fixed point. So we are not only considering the normal rotation, but we are also going to consider the rotation also from arbitrary pivot or fixed point. Okay, so we are going to consider this. Okay, so as usual we are including the stdio.h and conio.h. Okay, here we most required the mathematical header file, okay, that is math.h, okay, which is required because in rotation, 2D rotation, we are going to use the cos theta, sin theta and all these function. Okay, and this function definitely required to use the math.h. Okay, so we are including this mathematical math.h as a header file. Okay, now after this, as we have seen into the 2D translation program, okay, so we are using the Vx and Vy, and we stand for vertices or vertex x for x value and Vy for vertex y value. Okay, so we are considering here the Vx and Vy values, okay, which is of the original object. So it indicates the original object. Okay, then we are having Tvx and Ty, okay, which shows or which store the values of the transform object. Means after rotation, okay, the values of the object or the polygon is stored into the Tvx and Tvy. As we are going to divide the screen into okay, 4 quadrants, so we are having the center of the screen, which is xc is equal to 320 and yc is equal to 240. Okay, so nv indicate number of vertices. Okay, I is used for the for loop. Okay, so as we have seen in the 2D translation. Okay, so in I say our program is generalized because it will allow the user to draw any object by entering the number of vertices. Okay, so I'm having a separate function here. Okay, draw the original object. Okay, so to draw the original object, we are having the function draw original. Okay, so in the draw original object, first we go for clear device, then we set the color is equal to 15. Okay, so that my original object is drawn with the white color. So 15 indicate white color. Okay, 15 indicate white color. Okay, so we divide the screen into the 4 quadrants. So I'm drawing these two lines, horizontal and vertical line, to divide my screen into the 4 quadrants. Okay, and then we go for drawing the original object. Okay, so we are using this for loop. Okay, so this for loop is going to connect my first point to second point, second to third, third to fourth, and so on. Okay, so x of I and y of I is connected to x of I plus 1 and y of I plus 1. Okay, so first point is connected to second, second to third, third to fourth, up to the last value. Okay, but now we are having a separate line function. Okay, Now this separate line function is used to connect the last point to the first point or first point to the last point. Okay, so my first point is represented with the array value index value 1, and my last point is indicated with the array value nv. Okay, because nv indicate number of vertices, so I'm having 4 vertices. I'm connecting the first point and fourth point. Okay, so this is the function that we are using to draw the original object. Okay, then we are having a function to draw the transform object also. Okay, so this is going to draw the transform object after rotation. Okay, so once we apply the formula of rotation, whatever the values we are getting, we have stored it into the tvx and tvy. Okay, so this t indicate transform object value. Okay, we indicate vertex and x indicate x value. So we have taken the variable name as or array name as tvx and tvy. Okay, so to draw the transform object, okay, we are drawing the transform object with the yellow color, okay, or other than the original color. Original color is white. Okay, so we are going to draw it with the yellow color, or you can take any other color than the white, so that you can show that the transform object with different color. Okay, so here we are taking it as a yellow color. Again, I'm using the for loop to connect the points. Okay, first to second, second to third, a to b, b to c, c to d, and so on. And the last separate line function outside the for loop to connect the first point with the last point. Okay, to complete that particular object. Okay, so this function is used to draw the object. Okay, so our main aim in the main function, let us move to the main function. See, in the main function, okay, our aim is to take the value from the user as angle theta. Okay, so now here you can find integer gd and gd is equal to retake, gb is equal to dequate to initialize the graphics driver and graphics mode. Now, as I said, in the same program, okay, I'm going to consider, I want to rotate the object not only from the origin but from any other point or any arbitrary point. And to this, I have taken these values xr and yr. Okay, this is very important, xr and yr, because I don't want to rotate the object only from the origin. I want to rotate from any fixed point. Okay, so this xr and yr indicate rotation point. It is going to indicate the xr and yr indicate the rotation point. Okay, or we can also call it as a fixed pivot or fixed point. Means from which point you want to rotate. See, if I want to rotate the object from the origin 0 0, obviously the values of xr and yr will be 0 and 0. Indicate that I want to rotate the object from origin. Okay, but I can rotate it from any point, any fixed point. Okay, so that's why I have taken these values xr and yr indicate the rotation point. Okay, as we have learned this theoretically with the help of diagram. Now I am taking the angle of theta from the input from the user, that is float theta. So I have given the name of the variable itself as a theta. So this is what nothing but we call it as the angle of rotation. Okay, in degree. So I'm going to take this value to 90 degree, 180 degree, 45 degree. So this float theta indicate, and it is used or it is declared here, okay, because I want to take the angle of rotation also from the user, and generally user knows the angle of rotation into the degree. So user will enter 90 degree, 180 degree, 45 degree, and so on. Now here this is init graph, so we are going to take the initialize the graphics mode here. Okay, and then what is the step number 1? As we have seen in 2D translation is, we have to take the input of the object, take the object as the input from the user. So input object and draw the object or create the object first. Okay, so here we are taking to draw the object. I told it is a generalized program by asking enter number of vertices. So the user may want to draw the rectangle, may want to triangle, any polygon. Okay, so it is going to enter the number of vertices stored into the variable nv. Okay, so I'm using here ampersand nv where it is stored. Then we are using the for loop, okay, to take these values as input. Okay, so here what we are going to ask, we are asking enter user enter the point, percentage d indicate first point, second point, third point, and so on, first point of the object. Okay, then we are using the scanf and we are going to store these values in vx of I and vy of I. Okay, so Vx and Vy indicate my original object x and y value. Okay, so as I told, we have taken these values as a percentage of indicate float values, because whenever I'm going to calculate the cos theta, sin theta, multiplications are there. So it is better if you use integer, it is little bit difficult. Okay, so these values are also taken as a in the form of, we can say, the uh, float values. Okay, floating point variable. Okay, then after that, what we are going to do is we are going to draw the original object. Okay, so that the object will be visible to the user. Yes, this is my object, I want to rotate. Okay, now to rotate the object, okay, what is the first input I'm going to take is enter the angle of rotation. I think we are having the first input that we are going to take it from the user is enter the angle of rotation. We are taking this angle of rotation from the user, and then we are going to take also the so that is shown into the scanf. Okay, so I'm using scanf ampersand theta. Okay, now here it is possible that if you want to clear the screen or you can visualize the object. Okay, I will go for clear device here. Going to use clear device function. Okay, clear device, clear the screen, and then I will allow the user or ask user enter angle of rotation. Okay, that is taken as angle theta. And now here I'm going to take one more value from the user, enter fixed point xr and yr or arbitrary point. Okay, so this fixed point is nothing but point of rotation. Okay, I point enter a rotation point. Okay, I write it here. Okay, rotation, or we can say it is fixed point or arbitrary point. Okay, xr and yr. Now this indicate that I want to rotate the object. If it is I want to rotate from the origin, I will enter the values 0, 0. Okay, but if I want to rotate it from any other point, then I will give this value as the input, so that my rotation. So in the same program, I am going to show you the rotation about an arbitrary point. Okay, so this is what we are going to do. Now this is the formula, okay, that we are going to apply, that we are going to use. Okay, now, okay, this is the formula for rotation about an arbitrary point, but I just consider the normal rotation. Okay, normal rotation equation or formula. Okay, rotation equation. Okay, what is my normal rotation equation? I'm having my normal rotation equation. I'm just typing it here for your understanding. X dash is equal to, what we are going to use here is x cos theta. Okay, we are going to it as, okay, the x dash is equal to x cos, okay, into, okay, x into cos. I think I have taken the name of variable itself as a theta. I'm just typing it x cos theta. Okay, minus y sin theta. This is my normal equation that I'm using for x dash, and you know what is the y dash is equal to. Okay, so I'm just taking it as y dash is equal to, as per the formula that we have learned in theoretically, x dash equal to h cos theta, and y dash is equal to x sin theta, x sin theta plus, it is not minus, so it is x sin theta plus y cos theta plus y cos. See, this is the formula that we are using for normal rotation equation. X dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta. Okay, but now the same thing as I told in the same program, instead of writing two separate programs, we can say it is formula for rotation about arbitrary, or we can say it is from rotation point, a fixed point formula, or it is equation. Okay, so my equation for this is x dash. Okay, you can just observe here. Here I am having x cos theta minus y sin theta normal, but here what I'm going to add, I'm going to add xr. Okay, xr is my rotation point or fixed point. So xr plus, and now my value of x will be now changed from x to x minus xr. Okay, and y value is going to change from y minus yr. Remaining formula is same. So it is xr plus x minus xr cos theta minus, here actually I'm having y, that y will be changed now to y minus yr sin theta. Okay, similarly the y dash is equal to, okay, what is my, for y dash I'm adding yr. Okay, so that is my fixed point value, yr plus, again x is replaced by x minus xr sin theta plus y is replaced by y minus yr cos theta. Okay, so this is the formula that I'm using, or equation I'm using to rotation about arbitrary point or fixed point. Okay, so this is the normal rotation equation. Okay, but I'm directly using, instead of implementing normal rotation separate program and rotation about arbitrary point, I'm using the rotation about arbitrary point equation. Okay, because in this case, if I give the values of fixed point or arbitrary point as 0 0, means I want to rotate from the origin. Okay, if you want to rotate from the origin, give these values as 0 0. Okay, so that's why I'm using a simple one program, okay, which is rotation about arbitrary point. Okay, now this cos theta and sin theta function that we are having, cos theta function, sin theta function, which is used in the math.h header file. So in the header file math.h, we are using the cos and sin theta function, but this it is mentioned into the help. Okay, that cos and sin theta function which are used in math.h, they are uses the angle which is, okay, or the, okay, angle that they are using which is in radian, okay, not in degree. Okay, so what we have to do is, okay, I need to convert the theta from degree to radian. Okay, so I'm using the formula because my cos and sin theta function here requires the angle to be given in radians, not in the form of degree, but the user has entered this value in the form of degree. Okay, user is not aware about the, okay, radian, okay, angle should be given in the radian, so he has entered it into the degree, 90 degree, 45 degree, 180 degree, 270 degree. So I'm converting it into the radians because that is the requirement of my cos and sin theta function in the math.h header file. Okay, so what we are going to do, the theta is equal to theta into, we are knowing the formula to convert the degree into radian, that is the, whatever the angle I have collected into the, okay, degree, okay, the formula is whatever the angle you are having into degree angle into, okay, pi by 180. Okay, so I'm multiplying this with pi by 180. Pi means 3.14 value, so it is 3.14 divided by 180. Okay, so this is the formula. So 1 degree is nothing but it is equal to a degree into 3.14 means pi by 180. Okay, so here we are using this formula to convert the angle from degree to radian. Okay, so that I can use it in my program. Okay, then after this, okay, so we are applying the rotation. Apply rotation equation, okay, or apply the rotation here. Okay, we are applying the rotation over here. So this should be applied to all the vertices, all the points. So I'm having the for loop I is equal to 1, I less than or equal to nv, I plus plus. Okay, my array starts from 1, not from 0. Okay, so I equal to 1, so I'm having the condition I less than or equal to nv, I plus plus. Now what is my formula that I'm having? Okay, so this is my formula that we are having, just now we have seen, for the rotation about an arbitrary point. X dash is equal to xr. Okay, so xr plus x minus xr cos theta minus y minus yr sin theta. Okay, so now where my transform object will be stored, it is stored in t vx of I. Okay, after transformation, this is my x dash. Okay, so my x dash is t vx of I is equal to xr plus, this is my x minus xr. X is my vx. Okay, so it is vx of I minus xr into cos theta. Okay, correct, into cos theta minus, okay, so what is the value I'm having? I'm having the value over here is minus y minus yr. So my y is y vy. Okay, instead of taking only y, I have taken, because it is the vertex y value, so I have taken it as vy of I minus yr into sin theta. Getting me? So this is the same formula we are using. Then what is my y dash? Y dash is equal to t vy. T vy indicates it is my y dash. Okay, because that is my transform vertex y value I have stored. This is my yr plus, okay, x minus xr that is Vx of I minus xr means x minus xr into sine theta plus y minus yr. Y is my Vy. Okay, so this is Vy of I minus yr into cos theta. So this is the formula, okay, that we are applying for the two-dimensional rotation about any arbitrary point or fixed point. Okay, after that, what we are going to do, we are going to draw the original object, okay, and we draw the transform object over here to see the output, okay, and then we are going to close the graph. Okay, so this is what the program, okay, that we are having. So it is the one program which will not showing the normal 2D rotation, which is showing the rotation about an arbitrary point or fixed point. Okay, so I just save the program, F2 to save, yes, then go for F9 and control F9. Now here, as I told, okay, we can draw the triangle, we can draw the polygon, we can draw anything, but simply for the simple object, I take the number of vertices as a 3 and I want to draw the triangle. Okay, so enter the point of object, first point of object, as we have seen into a translation. I take the first point is, or first object point is 100, 100. The B point is 200, 100. Second point, third point is 150 and 150. Okay, getting me? 150 and 150. So this is my object I have drawn. Okay, now I want to rotate this object. Now, initially, okay, I want to rotate this object by 80 degree. Okay, how much degree? Okay, I will take the angle of rotation is 90 degree here. Okay, so with 90 degree angle, I want to rotate this object. Okay, and with the origin now. Initially, I will rotate in the origin. Okay, so I'm just entering these values. Enter angle of rotation is 90 degree. Yes. Now my fixed point, because I want to show the rotation initially with the angle or origin 0, 0. So I'm entering this rotation point is 0, 0. Okay, I press the enter. This is my original object, and you can find this is the object. Yes, we have got the very correct output. This is the rotation of this triangle. Okay, white triangle by 90 degree. Okay, so we are already learned the positive angle. Positive 90 degree indicate that it is in anti-clockwise direction. So counterclockwise direction it is rotated by 90 degree, and we have shown the transform object or rotated object. Okay, and with the yellow color. Okay, so now one more time, I just want to rotate this object by 180 degree. Let us see where it will come. Obviously, it will come into the third quadrant. If I rotate this object by 180 degree, let us check the output. Again, I execute the program, F2 to save, F9 and control F9. Number of vertices are 3. Again, I am giving the same values, 100, 100, 200, 100. See, 100, 100 is my A point. My B point is 200, 100, and my C point is 150 and 150. Okay, this is my original object. Okay, now I want to rotate this with the angle 180 degree. Okay, by 180 degree I want to rotate. Again, I want to rotate it from the origin. So my fixed point I am going to enter is 0, 0. So angle of rotation is 180 degree, but my rotation fixed point, arbitrary point is 0, 0, because I want to show initially the rotation, normal 2D rotation with the origin 0, 0. Okay, I just press enter. This is my original object. Yes. Okay, we have got the rotation of the same angle by 180 degree. I think it is shown into the yellow color as output. Okay, yellow color triangle, and I think we have got the very correct output. Okay, the triangle is rotated by 180 degree through the origin. Okay, origin is 0, 0. Okay, so I hope all of you understood it, okay, clearly how this 2D rotation is applicable. But now our program will not only rotate it by 180 degree from the origin, but I want to rotate it from a fixed point. Getting me? Fixed point or arbitrary point. Now let us assume here that the next input I am going to enter is my rotation point is A, or fixed point is A, not 0, 0. Okay, other than 0, 0, I want to rotate. So what is my A point here in the triangle? It is 100, 100. First point is 100, 100. Okay, so now I'm keeping in the triangle. You can find the left point, left side, first point is A, having the value 100, 100. I want to keep that point as a fixed point, and I want to rotate by 180 degree or 90 degree, whatever we want. So let us execute the program again. Okay, F2 to save, F9 and control F9. Okay, I'm drawing for simplicity the same object, enter number of vertices 3. Now here my first point, A point is 100, 100. Okay, 100 is my point A, which I want to keep as an arbitrary point or rotation point or fixed point. Okay, so I will give this 100 as a fixed point, so that keeping this fixed I want to rotate. Okay, my second point B is 200. My third point is 150 and 150. Okay, so this is my original object. Here, remember, I want to keep a point as a fixed point and want to rotate. So my rotation angle, okay, I will give 180 degree, because you understand how 180 degree rotation the shape will be, or the triangle will be displayed. Okay, but now my fixed point in this case, okay, is not origin, but I want to rotate this by fixed point is 100. The 100 is my point A. Okay, so I want to keep this as a fixed point and rotate the object. So let us see, this is my original object and this is my after rotation 180 degree. Yes, we have got very correct result. Okay, because my A point is fixed. So that is my fixed point and I have rotated it by 180 degree. The object will look like this. All of you are getting me? So this is what we can do. Now suppose I want to rotate the object. So another example, I want to rotate this particular object, okay, by 90 degree. Okay, so I want to rotate this object by 90 degree using the A as a fixed point. Same, I want to give it as a fixed point, but check how it will look like by 90 degree rotation. Okay, so I again execute the program. Okay, F2 to save the program, F9 and control F9. Okay, again I give the same object, easy for understanding, 100 A point, 200 B point, 150 and 150. Okay, so I want to rotate this triangle by a point again. Fixed point is A, but now 90 degree. Let us see how it will look like. 90 degree rotation. Fixed point is 100. Getting me? We have seen for 180 degree. Let us check for 90 degree. And the angle of rotation we are having or fixed point is 100. Original object. Okay, I press enter. Yes, this is my after rotation. It is very correct. Okay, we have got the correct output. A point is fixed and the object is rotated by 90 degree. 90 degree positive means anti-clockwise direction or counter-clockwise direction. My object will look like this. Okay, I hope all of you understood this. So as the last example, okay, suppose I want to rotate this particular object, getting me, from the fixed point as the C. Okay, C point is my fixed point and I want to rotate this by angle 180 degree. Okay, 180 degree means the object completely, okay, we can say semicircle value is 180 degree completely rotated, but now I want to keep the C point as a fixed point. Getting me? So let us check what will be the output. Okay, as the last example for understanding, F2 to save, F9 and control F9. Again, number of vertices I am giving 3. 100 is my A point, 200 is my B point, and my C point is 150. See, now I want to rotate this by keeping my C point, point number 3, 150. Okay, which is the center point. A, B, and C is center at the center, and having the 150. I want to keep this as a fixed point. By keeping C fixed point, I want to rotate by 180 degree. Let us see, this is my original object. Okay, so enter the values. Now rotation angle I want to give as 180 degree. I want to perform 180 degree rotation, but now my fixed point is C. I give my fixed point is 150 and 150. Getting me? So C point, center point. Okay, so 150 is fixed now. Keeping that fixed point, I want to rotate the object by 180 degree. Let us see the output, how it will look like. So this is my original object. I press enter. Yes. Okay, we have got the correct output. Okay, because C point, okay, is fixed and the object is rotated by 180 degree and we have got this as the correct output. Okay, so this is the program that we are having. Okay, one thing that we have to remember in this particular program, whenever you are going to implement this program, okay, then always remember, okay, you must apply this because you should convert the angle degree into the radian, because that is the requirement of cos and sine function. So you convert your degree into the radian by applying this formula, theta is equal to theta into, okay, take this as a bracket. Okay, in the bracket you should write pi by 180. Okay, so that is 3.14 divided by 180. then you can use this cos theta and sin theta function, okay, which is available in the math.h header file. Okay, so this thing is very important, this particular part, okay, that conversion of theta angle into the radians and then using the cos theta and sin theta function. Okay, so we are taking this as the, okay, how it will, the rotation will applied. Okay, I think instead of having two separate program, in the one program itself, I think we have done the 2D rotation from arbitrary or fixed point. Okay, this is what our today's demonstration. Okay, I just save the program. Yes, close the program. Okay, I hope all of you have really enjoyed the implementation of 2D rotation, okay, about the arbitrary point or fixed point, okay, how the object is rotated in the different angle. Okay, you can apply the minus 90 degree also, the different angles that you are having. Okay, so as an input you can give any angle as the input and also give the which point you want to keep it as a fix. If you want to rotate from the origin, you can give the rotation point as 0 0 and you can check the output. You can implement the program as well as you can check the output. Okay, I hope all of you have enjoyed the session. Okay, so we end our session over here. Okay, thank you